All right, we're going to begin chapter 6. And in chapter 6, we're going to talk a lot about risk aversion. What's not in the textbook, but maybe should be, is a discussion about expected utility theory. Okay, so as we start talking about risk aversion, I think it's important to understand a little bit about expected utility theory. We're going to cover that in this video here. Risk aversion is super important as we go forward. Risk aversion basically tells us the preferences of individuals that we're looking at, the preferences that they have for risk. Someone that is risk averse will avoid risk, or at least want to be compensated for the risk that they bear. So it's important to understand. Risk aversion generally. And so expected utility theory does this, I think, in a pretty straightforward way. All right. What we have on the y-axis is a utility, the utility of an individual that is a function of wealth. And on the x-axis, we have the amount of wealth. So you can think of, here's somebody that doesn't have any wealth, and here's somebody as they go through their career, they accumulate wealth. And anyway, here's somebody that's super rich, all right? The shape of the utility function will dictate the level of risk aversion that an individual has. For instance, an individual that has diminishing marginal utility, that is, as the first derivative of the utility function is positive and the second derivative of that utility function is negative with respect to wealth, someone that has diminishing marginal utility, a negative second derivative with respect to wealth, they will be said to exhibit risk aversion. Someone that has constant marginal utility of wealth, or somebody that has a positive first derivative of the utility function and a zero second derivative, is said to be risk neutral. And last but not least, there might be some people that are risk seeking, right? Both derivatives, the first and the second derivative of the utility function with respect to wealth, are positive. Those individuals are said to be risk seekers, okay? So let me just draw up a utility function here, and this is actually really hard to do. I'm going to do this on a laptop mouse pad, so forgive me because this is not going to look very good. That's about as good as it's going to get, okay? So you can see that this utility function is concave. There's diminishing marginal utility. The first derivative of this utility function with respect to wealth is positive. The second is negative, okay? So this individual is said to have, is said to be risk averse, all right? Now let me explain something here. So suppose we have a gamble, and this is how we determine a risk aversion. We have a gamble where we flip a coin. If you call it in the air and you get it correctly, you get $200. If you call it incorrectly, you lose $100, okay? So what we could do here is we could, let's say that right here, you're gonna lose $100, and over here, you're gonna gain $200, okay? So what I'm gonna do to determine whether or not an individual is risk averse, I'm gonna come up here and I'm gonna grab a line, and at this point, I'm gonna draw a straight line until I get to this point where the $200 outcome is, okay? So if the utility function is above this straight line between the outcomes of the different gambles, the outcomes of the gamble, if the utility function is above this line, the individual is said to be risk averse. Let me explain. Let's calculate the expected return of this gamble, and then let me introduce the concept of certainty equivalence, all right? So here you have the expected return of this gamble. If you flip a coin and you get it correctly, you got a 50-50 chance of that happening. So you have a 0.5 probability of that happening. And I'm gonna multiply this by, well, you got a 0.5 probability of you not getting it right. And I'm gonna multiply this by the loss. And I'm gonna add the 0.5 probability that you get this correctly, and I'm gonna times that by the gain, right? And so I get an expected return on this gamble of $50. So let me draw something here. So if I were to draw something, this $50 is going to end up right in between the negative 100 and the positive 100, or the positive 200 rather. And if I'm going to draw a line up to this point, I'm going to stop here at this straight line that I've drawn, okay? And I notice that the utility function is above this straight line that I've drawn. So what I'm going to do is I'm going to draw a line that's very straight despite what your eyes are telling you until it comes over here to the utility function. And then I'm going to draw a line back down towards the x-axis. And what happens is instead of 50, the expected return of the gamble, the certainty equivalent is much lower than that. That certainty equivalent might be, I don't know, say, let me just say something down here. The certainty equivalent might be something like $20 instead of $50, which is the expected return of the gamble. Okay? So if the certainty equivalent is less than the expected return of the gamble, then the individual is said to be risk averse. All right? This is super important. So let me undo some of this here. And let me talk about somebody that is risk neutral. So if I were to draw a utility function that is risk neutral, if I'm going to draw somebody with a risk neutral utility function, they have constant marginal utility, meaning that the first derivative is positive, the second derivative is 0. So that's somebody with a risk neutral utility function. And notice, if I'm going to say something about our gamble here, so here you have a 50-50 chance of getting the coin flip correct. And here you'd have -100, and here you'd have +200, okay? And if I were to draw a straight line between this point and this point, of course, it would just overlap with my utility function. That is, the utility function is neither above nor beneath the straight line that talks about the outcomes of this gamble, okay? So that's somebody with a risk-neutral utility function, all right? Let me get rid of that. And let me draw somebody with a risk seeker. In this case, the risk seeker has an increasing marginal utility of wealth. That is, the risk seeker has a convex utility function across wealth. Let me draw this. It's going to look something, that's horrible, but whatever. It's going to look something like that, all right? Let me go ahead and talk about the outcomes of the gamble. I have -100 on the wealth domain if you get it correctly. I have +200 if you get it, I'm sorry, -100 if you get it incorrectly, +200 if you get it correctly. Let me draw a line between these 2 points. And you can see that the utility function, is below the straight line that I've drawn between the outcomes of this gamble, all right? So what this means is if I were to find the certainty equivalent, let me go ahead and draw this. Again, let's say that this is $50, or the expected return of the gamble. I'm going to go and find this line, or find the point on this straight line that I just drawn. Here's $50. And notice that I'm going to have to go to the right of this line to find the certainty equivalent. And then once I hit the utility function, I'm going to draw the line back down towards the x-axis. So this might be 50. You might think I'm drawing with my left hand. That's not true. That was me trying really hard. I got 50 there, okay? And now the certainty equivalent might be something like 80 or 75. Let's keep them with straight lines, please. Okay, so the certainty equivalent is 75. That is, a risk seeker will, the certainty equivalent will be greater than the expected return, all right? So we can make some inferences about expected utility theory that I think are important. First, someone that is risk averse, the expected return is going to be greater than the certainty equivalent. For the risk neutral individual, the expected return is going to be equal to the certainty equivalent. And for the risk seeker, the expected return is going to be less than the certainty equivalent. Okay? So hopefully this helps you understand how economists think about risk aversion. This is going to be super important, I think, going forward. Okay?